Example 3. A company makes semi-annual deposits of $35,000 for 20 years into a fund earning 13% compounded quarterly. How much will have accumulated in the fund 10 years after the last deposit? Well, here we have semi-annual deposits, but the fund earns quarterly interest. So automatically we recognize that we have a general annuity. But let's concentrate on the time diagram first. And what we'll do is we'll start off with the fact that we've got 20 years of semi-annual deposits. So that means that we're going to have 0, 1, 2, 3. 20 years semi-annual means we're going to have 40 semi-annual deposits in 20 years. And those semi-annual deposits are of size 35,000. So we've got $35,000 at the end of every 6 months. So $35,000 per 6 months for 20 years, 40 deposits. So let's wrap an annuity bus around that and say, here's our annuity, and N is equal to 40 deposits of 35K. The question is, how much will be accumulated in the fund 10 years after the last deposit? So in other words, at year 30 or 10 years later, how much is in the account? So our focal date is really here. We want to know the final value of the deposits plus the accrued interest over that, certainly over that last 10-year period. So I think we're going to need to break this down into a couple of steps here. The first thing that we're going to have to do is find the final value of the deposits at the end of year 20, and then what we're going to do is to add compound interest to this for the last 10 years. So we'll add compound interest at the very end. So let's see now. Step 1 is to find the final value of the deposits, and the final value of the deposits is going to be given by the formula $35,000 per 6 months multiplied by the annuity factor 1 plus the interest rate per 6 months to the power of positive 40, because we're going to have a future value or a final value, and that will be inflated. It will include all the deposits plus the interest minus the 1 divided by the interest rate per 6 months. So now let's step aside to a small sheet of paper and work out what the equivalent interest rate is. Because we know we've got 13% compounded quarterly, we need to find the semi-annual rate. All right, so we've got a 13% compounded quarterly, and we need the semi-annual rate. So from the quarterly rate, what we're going to do is we're going to start off by dividing the quarterly rate by 4. We've got 4 interest periods in a year, so 13% divided by 4 is 3.25%. 3.25% per quarter. And so now we say, well, how do we find the semi-annual rate? Well, we're going to take 1 year for both rates and make them equal. So 1.0325 per quarter for 4 quarters, because there's 4 quarters in a year, will equal 1 plus my semi-annual rate, my rate per 6 months for 2 semi-annual periods in 6 months. And so now I've got the rate, the equivalency equation. So what I'm going to do now to solve this equation is I'm going to raise both sides to the reciprocal power on top of the I, or the unknown variable, and that will be 2. So the reciprocal of 2 is 1/2. So I'm going to raise this side to the power of 1/2 and do the same thing to the other side. So I'll end up with 1.0325 to the power of 2, 4 times 1/2 is 2, is equal to 1 plus I to the power of 1. So working this out on your calculators, you'll end up with 1.066056 and so on is equal to 1 plus I. Now what you can do now is store the 1 plus I value in memory 2. So we'll enter store memory 2 and subtract 1 from this, and we'll end up with 0.066056 and so on. That's 6.605% per 6 months. What we'll do is we'll store this in memory 1. So we've got I stored in memory 1 and 1 plus I stored in memory 2. We need both of those values in our annuity formula. So now we can go back and work on our original problem. And so now we can substitute into our annuity formula and say that the future value is equal to $35,000 per 6 months multiplied by the future value factor of 1.066056 and so on to the power of positive 40, take away 1, divided by 0.066056 and so on. Remember, you're going to use recall 1 for the interest rate and recall 2 for the 1 plus I value. And multiplying that by our $35,000, we'll end up with a final value of $6,314,920 and 15 cents. And that's going to be the value at year 20. Now we need to introduce a next step because we're going to take that $6.3 million and multiply that by compound interest factor for the next 10 years. So now we're going to take our final step and say that the final maturity value is equal to the principal multiplied by 1 plus I to the exponent n. And so we're going to start off with the principal of $6,314,920.15, and we're going to multiply that by 1 plus or 1.066 and so on. Now, how many interest periods are there? Remember that this is compounded semi-annually now, so there will be a total of 20 semi-annual periods, so 1 plus I to the power of 20. And when we do that calculation, we'll end up with a maturity value of $22,697,094 and 84 cents. So there's $22,697,094 and 84 cents after 30 years or 10 years after the last deposit.